Control connections. We have seen multiple times by now that the Cisco SD-WAN architecture decouples the control and management plane functions away from WAN edge routers. The solution implements these functions into centralized software-based controllers that oversee the entire network environment. Therefore, from the perspective of a vEdge router, the control and management plane functions are remote services that are communicated to the device. That is why each vEdge router must establish and maintain secure control connections to each Cisco SD-WAN controller. The SD-WAN controllers are software entities that run as virtual machines or containers, hosted either on-prem or in a public cloud provider. Each controller plays a different role in the solution and interacts with the vEdge routers through various protocols. For example, vSmart uses the Cisco Overlay Management Protocol, OMP, to communicate routing, TLOC, and service information among vEdges. vManage uses netconf to push configurations to devices, SNMP to collect data, and ICMP echo/reply to detect liveliness. To meet today's high standards for availability and security, each SD-WAN controller interacts with the WAN edge devices in a secure, resilient, and timely manner. However, when multiple control protocols are running in a network, ensuring that each one is compliant with the latest security policies is a complex task that quickly gets out of hand. For example, let's say we have a traditional WAN environment running BGP, OSPF, EIGRP, SNMP, and PIM. How do we make sure that each protocol is secured? Each one implements key exchanges differently, supports different encryption and authentication algorithms, and is configured differently. That is why Cisco SD-WAN has taken a different, more scalable approach when it comes to securing the control plane protocols. Every WAN edge router establishes one or more secured control tunnels to each SD-WAN controller. The tunnels are secured using a standard transport security protocol, DTLS or TLS. Then each control plane protocol, such as OMP, netconf, SNMP, etc., goes through one of the DTLS/TLS secured control tunnels, as is visualized in Figure 2. This technique ensures that the native security of these protocols, OMP, SNMP, netconf, etc., is no longer a concern to the overall security because they are communicated through secured tunnels that are encrypted and authenticated. DTLS versus TLS. Cisco SD-WAN supports two transport layer security protocols that vEdges use for control plane tunnels: DTLS, Datagram Transport Layer Security, defined in RFC 6347, and TLS, Transport Layer Security, defined in RFC 5246. Both protocols are very similar, and from a high level, they both serve the same goal to provide end-to-end transport security between a router and an SD-WAN controller. The main difference is that DTLS uses UDP and TLS runs over TCP. This means that they handle packet loss differently. TLS primarily relies on TCP for packet delivery. On the other hand, DTLS implements its own sequence numbers, fragment offsets, and retransmissions because UDP does not guarantee reliable delivery of packets. In the end, TLS is slightly more secure and reliable but slower. DTLS is marginally faster and more efficient, but less secure. However, the differences are so slight that they are pretty much the same in practice. By default, Cisco SD-WAN utilizes DTLS for all control plane communications because it is faster than TLS, and latency is essential when devices are managed remotely. However, the solution allows us to change the protocol to TLS easily. Control connections to vBond. We will explore the various control connections that a WAN edge router establishes, starting with the vBond controller representing the orchestration plane. Once we power on a vEdge router for the first time in an unconfigured state, it tries to find the IP address of vBond. The vBond orchestrator is the controller that glues everything together. That's why it is called the orchestrator. vBond validates the identity of vEdges, tells them whether they sit behind NAT in the underlay, how many vSmart controllers oversee the domain, And most importantly, what are the IP addresses of vManage and vSmart? In simple words, an unconfigured vEdge router needs to contact vBond to receive the necessary information required to join the SD-WAN domain. However, how could a brand new unconfigured router know the IP address of the vBond controller for a particular organization? Well, there are a few different deployment options that routers can utilize to discover the orchestrator's IP. CTP/PNP. A vEdge router can automatically discover the vBond IP address over the internet using a technique called Cisco PNP, plug and play, for IOSXi devices, and ZTP, zero-touch provisioning, for DTLS SD-WAN devices. At a very high level, the router simply makes a query to devicehelper.cisco.com or zetp.viptila.com over the internet, presents its serial/chassis number and certificate, and asks for the vBond IP address associated with its serial number. Bootstrap configuration. As an alternative option, a vEdge router can load a configuration file from a USB stick. The config file includes the vBond IP address, organization name, and everything else required so that the vEdge can successfully join the overlay fabric manually. And of course, the time-proven method that always works: a network administrator can configure everything through the CLI of the router, including the vBond IP address and the organization name. We will go through each deployment option in detail in the SD-WAN deployment chapter of this course. For now, let's see what happens after a vEdge router finds the vBond orchestrator's IP address. The vEdge router tries to establish a DTLS control plane tunnel to the vBond IP address over each available transport interface. In the example shown in Figure 3, vEdge 1 will try to form a DTLS control connection to the orchestrator over the internet and over the MPLS cloud. It will authenticate itself over each control tunnel and find whether it sits behind an NAT device along any of the paths. In the end, vBond will send back a list with the IP addresses and ports of all other SD-WAN controllers, vSmart and vManage. Both DTLS control connections are then terminated because the vEdge router does not need to keep permanent control connections to vBond once it receives all necessary information. Figure 3. Control connections to vBond. At this time, the vBond orchestrator will inform vManage and vSmart to expect a control connection request from that authenticated vEdge router. Control connections to vManage. Once a vEdge router receives the list with the IP addresses of all SD-WAN controllers from vBond, it initiates a single, persistent DTLS control connection to vManage over only one transport. The vEdge tries every transport network starting with the interface having the lowest port number, and it keeps the first successfully established connection permanently. If we look at Figure 4, all vEdges have two transport connections, one to the internet and one to the MPLS cloud. However, DTLS tunnel to vManage is established only via the internet. If a vEdge lost connectivity to vManage over this DTLS connection, it would form a new one through the other transport interface connected to the MPLS cloud. Figure 4. Control connections to vManage. When a vEdge router establishes a control connection to vManage, the controller provisions its configuration based on the device template attached to that vEdge. Control connections to vSmart. Following the successful DTLS tunnel to vManage, the vEdge router initiates a persistent control connection to the vSmart controller over each transport interface. You can see in the example shown in Figure 5 that all vEdges establish a DTLS tunnel to vSmart through the internet and another one through the MPLS cloud at the same time. Technically, a single control connection to the controller is sufficient for a vEdge to receive control plane information. Still, vEdges keep one permanent DTLS tunnel per transport interface for control plane resiliency. When a vEdge router establishes at least one DTLS control connection to vSmart, it starts a single OMP peering session. The router then advertises its local networks, TLOCs, and service routes to the controller via OMP. Upon receiving the information, the controller recalculates the centralized RB routing information base, based on the defined policies, and redistributes the routes to all other vEdge devices using OMP updates. The following output shows an example where a vEdge router has 3 DTLS control connections to the same vSmart controller over each local color. Although there are 3 DTLS connections to vSmart, the router has established only one OMP peering session with the controller, as shown in the output below. Notice that the IP endpoints of the OMP peering session are the system IP addresses of the vEdge and the controller, as illustrated in Figure 6 below. Figure 6. OMP peering session. The OMP peering session works the same way as a BGP peering session between loopback addresses. Although multiple IP paths exist between the BGP peers, the BGP session itself is only one and can use each available IP path at any given moment, according to the routing table. Similarly, an OMP session is established between the system IP addresses and can use each available DTLS control connection for transport between the vEdge and the controller. Control Connections Overview. When a vEdge router establishes the control plane connections to every SDWAN controller and receives the route information from vSmart, it joins the overlay fabric by establishing IPsec/GRE tunnels to all remote TLOCs across all local WAN transports. The data plane IPsec tunnels should not get confused with the DTLS control plane tunnels to the SD-WAN controllers. It is also important to note that the concept of transport locators (TLOCs) does not apply to controllers. All SD-WAN controllers have a single ordinary L3 interface that terminates DTLS/TLS connections, and this interface does not have TLOC configuration, color, encapsulation type, tunnel group, etc. Figure 7 summarizes all control plane connections that a vEdge router establishes. One transient DTLS control connection to the vBond orchestrator over each connected WAN transports only during the onboarding process. One persistent DTLS control connection to vManage over a single WAN transport. One persistent DTLS/TLS control connections to vSmart over each connected WAN transports. IPsec tunnels to all known remote TLOCs with different site IDs over each available WAN transports. A BFD session is automatically started over each IPsec tunnel and cannot be disabled. To check the control plane tunnels of a vEdge, we use the command show control connections as shown below. Thank you for watching. Don't forget to like, subscribe, and hit the notification bell for more insights on Cisco SD-WAN and network technologies.